All right, so this is homework 7. I'm going to split homework up 7 up in several different ways. I'm actually going to solve this 3 different ways, just because I think they're probably the 3 most common ways that you might have done this. I'm going to go ahead and give you the, if you're trying to navigate this, I'm going to give you those 3 solutions over here. I'm going to give you the times. I'm going to have to come back and write them in later. So the first thing I'm going to do is I'm going to do the geometry. Okay, and then I'm going to do solution 1, which will be, it'll be using sections. And we're going to call that, we'll do the left-hand side first. Okay, that's my preferred method to solve this. That's how I solved it. Probably the least preferred would be sections using the right-hand side. And I don't like that because you have to get the reactions, but we'll talk about that when we get there. And then the, kind of the medium one would be to do joints. Okay, and we'll talk about that one later then. Okay, so what I'm going to do is I'm going to put the time that these things start. So obviously, the geometry starts at like 1:07. Okay, so let's go in here and let's do the geometry. The geometry is gonna hold for every. We're going to use it for all of them. Okay, so here we go. So let's zoom in. And let's start solving for some geometry. Okay, so somebody emailed me, I can't remember who, and they said, well, I need some numbers here. So I gave them 12 feet right there. And so what we're going to do is, I think, to start with, I think I'm going to just start with some angles, and then we'll go from there. So the first thing I want to note is, this is a right angle right here. Okay, and so if that's a right angle, that means that, let's see. Okay, that's probably not exactly where I wanted to start, but I'm gonna draw some guidelines just to help me out. Okay, so drawing these should help out in a few ways. I think the first thing that we want to note, maybe I'll do this all in green. Okay, so this is a 30. Let's use an actual pen though, because it'll actually be visible. Okay, so the first thing we want to note is that this is a 30-degree angle. This is a right angle, as I mentioned a second ago. So it means this is a 60-degree angle, which means this one right here is a 30-degree angle. Okay, so the whole thing is a 30, 60, 90 triangle, which is kind of cool. So we can also then stare at this triangle EHG, and we can note that that is also a 30, 60, 90, right? Because we've got 30 right here, we've got 90 right here, so this one right here is 60. Which is also nice because it establishes that this is 30, this is 60, this is 30, 60. All those are adding up to 180, which, has to happen anyway, right? It also means that this line right here is, in fact, vertical, which is awfully nice thing to know, right? So here's our vertical line right here. Okay. And let's see, what else can we do? Okay, so we need some more angles, some more things that are going to be useful for us. Okay, so we're going to use the fact that this is a 30-degree angle right here. And that means that this is an alternate interior angle, since this line here and this line here are parallel. So this is a 30. We also could have gotten that by making note of the fact that these 3 have to add up to a right angle. Okay, and that helps us with our forces, right? So our force right here, this is because this is a right angle, then that means this 30 and this angle have to add up to 90. So this is a 60-degree angle, which is going to be very helpful when we are splitting this force, right? So this force, if I zoom way in on it, come on, let me zoom. Oh, that's pretty far. Anyway, so if I zoom way in on this force, I'll actually, I think I'm actually going to delete this 60, just make it a little smaller so it's not so like in my face, right? So this is a right angle, that's fine, we know. Great, you're really good at being a right angle. So this is a 60-degree angle. And so this force now, like I've got this downward, that's my Y direction force. This is my X direction force, like such. Okay, and so this is a right angle because my X and Y are, perpendicular to each other. And so this is a 30, 60, 90. And it means that basically this, so the hypotenuse is 1,000 pounds. And so this vertical right here, depending on which angle you want to use, is either 1,000 pounds times the cosine of 30, because it's the adjacent to that 30-degree angle, or it's 1,000 pounds times the sine of 60 degrees. Okay, it just depends on which angle you want to use. Either way, that's going to end up being, if you plug that into your calculator, 866.03 pounds. Okay, this horizontal right here, which there isn't really space to write, depending again whether you want to use this 30 or the 60, is going to be 1,000 pounds times, it's either the opposite of that 30, so that in which case it would be the sine of 30 degrees, or it's 1,000 pounds times the cosine of that 60, because it is the adjacent to that 60. Okay, either way, that is 500 pounds. Okay, so all of these forces, all of these 1,000 pound forces have the same look. So I'm going to just kind of draw it above it. And probably as we go, I'm not going to do the trig every time because that seems a little silly, right? But, you know, we could just draw a little triangle that will represent this force for us. And it looks like this, you know, 500 pounds in the x direction, 866.03 pounds in the y direction, and 1,000 on the diagonal. All right, so let's zoom back out now that we kind of got these forces figured out. I mean, hopefully you can see that they're all, you know, on the same 60-degree angle from the horizontal. Okay, and this one right here is 30, right? Because this is a right angle right here. All right, so we can say then that this is a 30-degree angle, right? Just as this is a 30-degree angle, just as that one, just as this one's a 30-degree angle. Oh, wait, I forgot I was doing this all in green. Anyway, so because these two are right angles, this part right here is a 60-degree angle, which means this middle triangle is an equilateral, 60, 60, 60. So if I can get one side of that sucker, I can get all the sides of that sucker, which is pretty cool. Okay, so I think we're now at the point where we can't really do much else with the you know, angles without a little bit of help. I guess, you know, we know that this is a 30 right here, right? Don't we? Do we know that? We don't know that. We would like to know that. We would like to believe that that's 30, but we don't know that for sure. Because we don't know anything about the direction that F is in. Okay, so let's start doing some sides. So if we look at the triangle as a whole, okay, so I'm going to draw one giant triangle here. Looks like this. You know, so this is the whole big triangle. We'll note that the whole big triangle is a 30, 60, 90. Oh, well, if I could keep my pen straight. So that whole thing right there, this is the only side we know is one of the sides of that triangle. So for that big triangle, I can say that okay, well, sine of 30 degrees equals, so the opposite of that 30 is 12 feet, and the hypotenuse of that is A to G, right? AG. So I can say AG equals 12 divided by the sine of 30, which is 24 feet. So we can, you know, I can now say, okay, cool, I know this is 24 feet, which is like totally and amazingly useful, right? To go from there to there is 24. Okay. And then I want to get A to H down here if I can. So let's go ahead and do that. So from here to here, right? That's on the same triangle, but that is the adjacent, right? So cosine of 30 degrees equals the adjacent, AH, relative to the hypotenuse, 24 feet, right? So AH equals 24 cosine 30, which is 20.785. 20.785 feet. Okay, so this is 20.785 feet. All right, so now what we're going to do is we're going to step over and we're going to look at this 30, 60, 90 here. So this is what? EGH triangle. Okay, we're going to use the exact same relationships. Okay, EGH But of course, we're going to have, we have a different angle. We've got a 60 degree. I'm using the bottom angle. We could use the top angle if we wanted to too, but I'm just going to go ahead and use the bottom angle. Okay, and let's just erase all this business, right? So we're going to use a sine and a cosine. Okay, so relative to this 60 degree angle right here, sine of 60, cosine of 60. The sine of 60 is the opposite, 12 over the hypotenuse, which is e to g, so it's e to g, eg. Okay, so eg equals 12 divided by the sine of 60, which is 13.856 feet. Okay, the cosine of 60, okay, that's going to be the adjacent over the hypotenuse. Okay, so the adjacent is EH over the hypotenuse, which we decided was 13.856 feet. So this is going to be 13.856 feet. And so that's pretty cool. So EH is 13.856 cosine 60, which I believe is the same thing as just half, right? Right, so it's going to be equals 6.9282 feet. Okay, so this number right here from E to H, 6.9282 feet. Okay, so we've got everything to go with that triangle. Okay, that means this distance right here, okay, that distance is going to be 20 minus that 20.785 minus that 6.9 whatever, and so we're left with 13.856 feet. Okay, which is pretty cool. Okay, let's go ahead and get this side right here, right? Because we've got another 30, 60, 90 triangle right here. Okay, because I know this one's going straight up. All right, so let's go ahead and get that vertical right there. So I'm going to do that sine and cosine stuff again. And I'm just going to keep using this this 30 degree angle because I've got it and I'm happy with it, right? So the opposite is this side, which is what? DE, D to E. So DE over this, oh no, the hypotenuse. We don't know the hypotenuse. DE, the vertical over the hypotenuse. We don't know the hypotenuse there. So let's not use that. Let's use the tangent, right? Right, so let's use the tangent. Okay, once this thing will erase for me, which it has no choice. Okay, so let's use the tangent instead. Okay, because we know the adjacent is the opposite we're looking for, so the tangent makes the most sense. Okay, so the tangent of 30 equals the opposite, which is DE, over the adjacent, which we know to be 13.856 feet. Okay, so we'll take that number multiplied by the tangent of 30, and we're at 8 feet. So 8 feet is a nice clean number. We really like 8 feet. Okay, that's DE. Okay, and now if I want I can use the cosine of 30 or the sine of 30. It doesn't really matter to get the distance from A to D, right? So so the cosine will be the adjacent, 13.856 feet over the hypotenuse, which is going to be AD. So AD equals 13.856 divided by the cosine of 30. AD is 16 feet. Okay, so that's nice. Okay, so AD, so from here to here is 16. Well, really, from A to D, come on, you can do it. Just, what's wrong with you? Did my pen just die? Nope, my pen didn't just die. The computer's being a jerk. Okay, come on. A to D is, that's 16 feet in total. Okay, but really the most important thing is it tells me that this distance right here is 8 feet. Okay, so now we know, let's see if we can mark maybe in purple the distances we know. We know this one. We know this one. We know this one. And we know this one, right? And we know this one in total. Okay, and so let's go back to a few other things that we know they're going to give us a few more things. I know this is 8 feet, and this is 8 feet because this is an equilateral triangle. Okay, so that gives me these distances here. And because this 8 feet and this 8 feet and this unknown add up to 24, I know that this is 8 feet right here, right? So we can go ahead and mark that as a known. Okay, let's see. Okay, so there's a little bit of chicanery going on here. So in order to get, you know, basically what I want to do right now is I want to split this 13. I want to know where this point is right here. The temptation is to just put it in the middle. That's going to end up being okay. But here's the reason why. So if I look at this flat line right here, I can note that this right here, let me erase a little bit here. Okay, so because of, like, you know, vertical angles, this is a 30 degrees. Because these two have to add up to 60, this is also a 30-degree angle. So that's, like, really nice and helpful. But what's cool about this, you know, and I'm, you know, running out of colors to make things pop here, but we've got a triangle right here, like this, right? That's a 30, 60, 90. And that's really helpful, right? Because using this hypotenuse right here, 8 times the cosine of 30, I can get this side right here. And if I do 8 cosine 30, I get 6.9282 feet, which means that you know, is from here to here, right? So this is 6.9282. And that means that this is also 6.9282 feet, right? Unfortunately, I'm not seeing a similar way to split this one. There probably is one. I'm just not seeing it at the moment. You know, because, you know, I would need a line, you know, to do the exact same thing, I would need a line parallel to this one that goes like this. But I don't think we're actually going to need that point. So we're just gonna go with it like this. So now at this point, I've solved for, let's see, for sides. I've got this side. I've got this side. I've got this side in total from here to here. I don't know this, right? So really, what I'm missing is, you know, if I knew, you know, because this thing could be like that, it could be like that. You know, there's no way to say what the angle is here, at least none that I can see. And it ultimately, I don't think it really is going to matter, precisely because this is a zero force member. This one is also a zero force member, but it's good to know the location of this force in X and Y, okay? So anyway, so that's an awful lot of mess. But if you come back here, if you're struggling with some other part of this and you're like, I don't know how to do this, and you're like, okay, well, come back here and look at it, and hopefully this will help you figure out where I got the values that I'm working with, okay? So what I'm going to do now is I'm going to go over to the next step over here, and let's see, I'm going to call this solution 1, or let's just call this you know, right-hand side, left-hand side sections, left-hand side. Okay, so sections, okay, left-hand side. And I like this, doing it this way, because, so, you know, if you were to like walk into this thing and you're like, okay, we have to solve for CE, BE, and BD. Well, in purple, let's see here, BD is this one right here. CE is this one right here. Sorry, I'm kind of going out of order here, but you know, you get the point. Okay, and BE is this one right here. So if I choose to cut it, like I want to do a cut that's going to have all three of those. So this is the obvious place to cut it, okay? But then the question is, do I do the left-hand side or the right-hand side? And I would choose the left-hand side because then I don't include these things here, which are, you know, where it interacts with the outside world. I don't want to have to solve for that, okay? So what I'm going to do is I'm going to draw a free body diagram of this side like that. And so what that's going to do is that's going to give me the things that I need, right? And I'm not going to draw the geometry on this. I'll draw the geometry on my free body diagram of that little subsection. Okay, so let's see. So let's draw that. I'm going to go ahead and pause it while I do this because I don't think that you need to listen while I do this. Okay, so if I redraw this, this section, right? So I've basically split it off from the rest of the world at these three locations. So I've replaced those with forces. Okay, I've drawn all of my geometry on here. And the key here, of course, is don't forget these external forces. Then this is what you get. Okay, so I'm going to zoom in here. And it looks like I drew it a little crooked or something. I'm not really sure why it looks crooked like that, but maybe it's just late and, you know, I'm an idiot. I don't know. Anyway, so when we have this section, notice also I've included point E here, and that's just in case I want to take the moment there. I haven't really decided where I want to take the moment yet, or if I want to do the moments first at all. Okay, so I like to think about my unknowns. X, Y, and Z will be the moment, right? So how many unknowns do I have in each? Well, in the X direction, hopefully you can see I've got BD, BE, and CE are all unknown. So that's 3 unknowns. That's like really annoying. We don't want to start with X. In the Y direction, I've got BD and BE are both unknown. So that's 2 unknowns. And then in the moment direction, it depends on where I take the moment, right? So there's really 2 really nice places to take a moment here, and I'm going to put dots on there in purple. I could take it at E, because if I take it at E, that's going to get rid of BE and CE, because both of those go through there, right? But the other option, and the one that I think I'm going to go with here, is to do your moment at B. Because if I do it at there, I'm going to get rid of both BE, BD, and this 1,000, right? So that's, 3 things that I'll have to deal with. So I'm only going to have 2 that I need to deal with that, and that's that 1,000 and the CE. So that's a very pretty equation with only 1 unknown. Okay, so we'll do that, and what that's going to do is that's going to reduce my X equation down to 2 unknowns, although I'm still going to have 2 in the Y direction. So these 2 I'm going to have to solve simultaneously. Okay, as you know, when I was in high school, they called it simusolve. Anyway, so let's start by doing this moment equation right here. Okay, so I'm going to do it at point B. So the sum of the moments at point B, and I'm going to do this little thing right there, equals 0. Okay, and we'll start with this 1,000 right here. So I've got now notice that this is a right angle. So my R is just going to be this 8 feet to go back to B. Okay, so it's just going to be 1,000 pounds times the moment arm, 8 feet. And it looks like that's going to cause a rotation, around B that's positive. Okay, and then CE, which I need to deal with right here. Right, now it's got a moment arm of 4 feet, right, because that 4 feet is at a right angle to CE. So we'll say CE times that 4 feet, and it's going to cause a rotation in that same direction, equals 0. So CE equals, it looks like it's going to be negative 2,000 pounds. Okay, and this will be the first of 3 times we get that solution in this particular video. Okay, so there you go. So that's one of our 3 unknowns down. So now we'll do X or Y. It doesn't really matter which one, because they both have 2 unknowns at this point. Let's just go X. Okay, I usually go X then Y if there's no particular reason for either one of them. So in the X direction, we've got this 500. We've got this 500. So we've got 2 times 500 pounds. Okay. Let's see. I've got CE right here plus CE, and then I've got BE, or the X component of BE, which is BE times the cosine of that 30 degrees, and then plus the X component of BD, plus BD times the cosine of 30 degrees equals 0. And let's see, so if I rearrange this and plug some things in, so this becomes 1,000. CE is negative 2,000 pounds, all right, plus BE plus BD. I'm going to factor out that cosine 30. Okay, so then I'm going to end up with BE plus BD. I'm a little bit out of alphabetical order here, but I think I think we can live with that. Equals, if you use your calculator, 1154.7 pounds. Okay, so that's one equation. I'll go ahead and just call it 1. Okay, because we're going to get, because we're going to have the same two unknowns in the y direction. So we're going to need to solve this, like, doubled up or whatever. Okay, so I'm going to zoom out a little bit just so I can have some space. So sum of the forces in the y equals 0. Okay, so now I've got this and this are both downwards. So -2, there's two of those, right? 2 times -866.03 pounds. Okay, I've got the y component of this one, so plus BD sine of 30 degrees, minus the y component of this one, minus BE sine of 30 degrees equals 0. Okay, so we're going to do basically the same algebra we did last time. I'm going to take this number and bring it over to the other side. And then I'm going to get BD minus BE times the sine of 30, which is a half, equals, 2 times that number, which I forget what it's like, 17 something or other. 1732.1 pounds. And so we solve this, we'll get BD minus BE equals 30, oh, wait, there's a negative sign here somewhere. Is there a negative sign? No, it's a positive. Come on now, you can write 30, dadgummit. 64.1 pounds. Okay, I'm going insane now, okay. So anyway, so we got these two equations, and you'll notice if you watch the full video, these two equations are going to show up an awful lot, okay? And so what we're going to do, basically, we could solve one of these and plug into the other one. That's totally fine. In this case, it's easier. We're just going to add them. Okay, so what I'm going to do is I'm going to say equation 1 plus equation 2. And the reason that I'm doing that is because I've got a negative BE right here and a positive BE here. So when you add it, they're going to cancel. So the left-hand sides, if I add them, I'm just going to end up with 2BD. And the right-hand sides, if I add them, is 4618.8, I believe. 8 pounds. And so then I can solve that equation. I get BD equals half of that, which is 2309.4 pounds. Okay? And then I can plug that into either equation 1 or equation 2 or any other equation that I feel like that's going to give me an answer. But of course, 1 or 2 is going to be the easiest. So I'm just going to plug that right into equation 1. So it's going to go right in for this number right here. So I'm going to say BE plus 2309.4 pounds equals this, 1154.7 pounds. Okay, so again, we're just plugging this solution into equation 1. Okay, so BE then equals negative 1154.7 pounds. Okay, so our total solution then is CE, let's see here, BD, BE. I like to do this in alphabetical order. Okay, we want 3 sig figs, so I'm going to go ahead and do these in kips. So this will be 2.31 kips. This one will be 1.15 kips, and this one will be 2.00 kips. And then because I assumed everything was in tension, everywhere I have a negative sign is in compression. And I had both of those were negatives, and this is a positive. So that is your solution. Okay, so we're going to zoom out. Come on. So that's the first of many solutions. And we're going to do sections, and we'll do the right-hand side. Wait, is that the order I said I was going to do this? I think it is. Let's make sure I got the order right here. Sections right-hand side. Okay, let's do sections right-hand side. Okay, so we go down here. We'll do sections. Okay, right-hand side. Okay, with the drawback here being, okay, again, remember, we're looking for this member right here, this member right here, and this member right here. So we're going to cut it right through the middle of all of them. But this time, we're going to do the right-hand side. So we're going to have to keep those reactions involved in this. Before I go and start solving for the reactions, I want to mention just real quick, you know, this is a pin right here at G. So I'm going to have GX and GY, right? But this one down here is also a pin, but I'm only going to have HX, so I'm just going to call it H. And the reason that I'm not going to have an HY is because this right here is a two-force member. Okay, so when you have a two-force member, remember it can only be in tension or compression, right? So there's no reason to consider, you know, it can't push in, you know, outside of its axial direction. Okay, so we're not going to worry about that. Okay. On the other hand, you know, the drawback to doing this side relative to the other side, and the reason that this would be my least preferred solution, is precisely because we have to solve for these, right? Because if I just go straight for those purple members, well, you know, I've got forces here, here, and here, so that's 3 unknowns, 1, 2, and 3. But I've also got these over here, 1, 2, and 3. So that's 6 unknowns. So I need to get these 3 from the global equilibrium. Okay, so that's kind of the lineup here. Let's see, is there anything else of note here before we begin? I don't think so. I think we can just begin. So what I'm going to do is I'm going to pause it while I draw a free body diagram so that we can solve for the whole. Okay, and I'll do it, if you watch the last one, I'll do it just like the last one, and I'll try to be very neat. Okay, so I think this is, you know, pretty good representation of global equilibrium. You'll notice I put all the distances in kind of that, you know, kind of a pencil-y looking red, and then I put, the forces in blue. Hopefully that would make things stand out, and the angles are in pencil-y gray. Okay, one thing I want to note is I did the force here, you know, the force triangle. I only did it on this 1,000 pound force. Obviously, it applies to all of these, okay? But I just didn't feel like muddying up my diagram too much. Okay, it turns out that I don't think we're actually gonna, well, we will need those, never mind. All right, so before we begin, we want to think about how many unknowns we have in the x direction, the y direction, and then the z direction, which would be the moments, okay? So in the x direction, we've got the unknown of g and h, so that's 2 unknowns. In the y direction, we just have gy, it looks like, so that's just 1, so that's great. We will probably solve that one. And then the z direction, well, how many unknowns do we have? Well, it depends on where we solve it, right? And so we need to pick a good spot for the z direction. And, you know, the obvious point is right here at G. And so if we pick the point right there at G, then that gets rid of GY, GX, and this 1,000 pound force. So that's going to be, so that's going to leave just this H down here. So that's a 1 unknown. So we'll do some forces into Y first, and then we'll do Z, and then we'll come back and grab X, right? You know, because really to get X, we may need to make sure to do this one first, right? Because that's what we're going to solve for H. Okay. Oh, also, you know, summing forces at H would have been a good location as well. Because if we chose there, this H would have gone away, and this GY would go away, and that GX would remain. Okay. So anyway, so let's just start, and we'll do the Y direction. Let me get a black pen because, you know, working in purple is a little strange. I know some of you are LSU fans. I am not. So we will not be doing that. Okay, so in the vertical, we've got sum of the forces into y equals 0. And let's see, what forces are we working with here? Okay, I've got 4 of these going down, right? So I've got 4 times that negative 866. So 4 times negative 866.03 pounds. Okay, and then I've got this gy going up plus gy. And I think that's everything. So that's a really nice equation, right? So we can solve that, and we get gy is 3461.64.1 pounds. Okay, sweet. Okay, now we want to do the moments because, again, 1 unknown. I'm going to go ahead and do them at G. By the way, the advantage that doing it at G has over at H is that we're getting rid of this 1,000 as well, okay? So the sum of the moments around that point G equals 0. Okay, and I'm going to go force by force, I guess. I'm going to start with this 1,000 right here. So that 1,000 pounds. You could have used the two split forces here. That's going to be a lot more complicated way to do it. The key here to note is that this is at a right angle to this distance right here. So it's going to be, 8 plus 8 plus 8 all the way there because it's at a right angle to that line. So it's perfect, right? So its moment arm is 24 feet. And it's causing a rotation in that general direction, okay, which we'll note is positive, okay? So then we're going to do this 1,000, okay? It's rotating in the same direction or causing rotation in the same direction, and its moment arm is only 16 feet, okay? And then we'll do this 1,000, okay, and its moment arm is 8 feet, okay? And let's get this out of the way because it's kind of annoying. And then, this 1,000 has a moment arm of 0. GX has a moment arm of 0. GX and GY both have moment arms of 0. So then we just got to deal with this H, right? So H is also going to cause a moment arm, a positive rotation, right? Because it's going like that relative to G. And its moment arm is 12 feet, okay? Again, notice there's a right angle between that line and this thing right here, right? So that equals 0. So if we solve, sorry, my microphone went off for a second, but if we solve for H there, we end up with a negative 4,000 pounds. Okay. Again, it's not that solving these reactions is all that hard. It's just that if we can avoid doing this, it would be nice to do so. Okay. So now we'll go in the X direction. Now that I have both of those. So now in the X direction, I only have one unknown, right? Because I've eliminated one of them. So let's go ahead and do that. So sum of the forces in the X direction equals 0. Okay. I've got 4 of these 500s, right? One here, one here, one here, and one here. So I've got 4 times that positive 500 pounds. Okay. I've got GX plus GX and H equals 0. Right? So I want to plug in for H that negative 4,000 pounds. Okay? And once I do that, I get 2,000 here. I get negative 4,000 there. And so if I solve all this, I get GX equals 2,000 smackaroonies. Right? Okay. So once we have these things done for us, okay, so what we're going to do, I'm not going to erase my work because I just, I'm just so proud of it. I don't want to erase it. So I'm going to go back up here, and what I'm going to do is I'm going to draw, I guess I have a highlighter, so maybe I can highlight this section that I'm going to draw. I'm going to draw this section, right? But this time, I know what the forces on the outside of it are. I know these. And the only unknowns will be here, here, and here, right? So I'm going to, obviously, well, maybe not obviously, but what I'll do at this point, though, is I'm actually going to, when I write these guys, I'm going to write them in using these values, okay, because that's going to make my life a lot easier. So what I'm going to do is I'm going to pause it while I redraw that down here. Hopefully you have it in front of you. It's also going to be nice because I finally get to get down onto this graph paper. But yeah, so I'm going to pause it while I draw. Okay, so I've just spent entirely too much time drawing this. Okay, now you're kind of thinking, wait a second, Wagner. You said you were just going to draw a section of the right. Yes, you're right. I was just going to draw a section of the right. And then I started drawing it, and then I realized that I was drawing too much. And then I thought, you know what? It's not that unuseful to do this. So we just want the right-hand side. So here's what we're going to do. And this is kind of what you're supposed to be doing when you draw a free body diagram, is you're erasing the stuff you don't care about. Okay, we're going to leave point C there. Because do we need point C? No, we're not going to use point C. So we're going to go there. I'm going to leave point B there because I think point B might be useful just to know where it is, right? Let's see here. Let's see if we can't. Yeah, there's point B more or less. right? And these are the things we're trying to solve for, like this, right? Boom. Okay, so that's what you're doing when you draw a free body diagram, is you're saying, you know what, I'm just going to cut away the world. No, let's use a pen here. And when I do cut away the world, what I'm going to do is I'm going to replace the world with forces, right? Because, you know, so here's B, and B might be useful. We don't know for sure. But what B gives us is, you know, we might use that to get, you know, we might take a moment at B instead of at some other location, right? Just because it's convenient for us, okay? So what we're doing is we're replacing the world with forces, okay? And I'm assuming in this case that this force is tensile. I'm assuming that this force is BE, is tensile. And I'm going to assume that this force right here, CE, is also tensile. And so the point is that we replace the entire world with these forces because that's how the world interacts with this right-hand side, is through forces at those locations. Okay? So now we just gotta, excuse me, we just need to solve this sucker. Okay? We've got 3 unknowns. Okay, so we just gotta say, okay, let's see. X, Y, Z, you know, blah, blah, blah. So in the X, we've got 3 unknowns. X, well, it looks like I'm working with blue here. In the Y, we've got BD and BE, so we've got 2 unknowns. And what about the Z direction? Well, obviously, as usual with the Z direction, depends on where we take it. And I think, you know, there's 2 really good spots. I think this is E would be an excellent spot, right? Because I would get rid of my 4,000, get rid of CE, get rid of BE. It looks like on my key I did it at B, which is not as good a spot because it doesn't get rid of this 4,000. But if we do that, the only unknown is CE. Okay, so I'm just going to do it there because that's the way my key is. You could do it somewhere else if you want. You could do it at E would be another very good spot. Okay, I don't know why I didn't do it at E. You know, short-sightedness. Okay, so 1 if we take it in the right spot. Okay, so let's go ahead and do some of the moments at B, and you know, there's kind of a lot of forces here. I mean, look at all these forces. 1, 2, 3, 4, 5, 6. Okay, so one thing that I find to be helpful is to count the forces because each force is going to be a term, right? There are 2 more forces down here, but neither of those are going to be terms, right? So we want to know before we even begin, how many terms are we going to end up with? So I guess I'll do it right here. Sum of the moments around point B, okay, here's a positive direction, equals 0. Okay, so I'm going to start with, I guess I'll start with CE, what we're looking for. So CE, now its moment arm, going back up to B, is this distance right here, which unfortunately I erased, but that distance was 4 feet. I shouldn't have erased it. Anyway, so that's a negative sign. You can kind of see, you know, the similar 4 feet. And this 4-footer really is a question mark. I don't know why I put that there. Anyway, all right, so then let's do this 4,000 here. 4,000 kips, not kips, pounds. Okay, this should be a pounds. And its moment arm is the same, right? Because here's the right angle between the line of action of that force. And so that's going to be 4 feet. Okay, and both of those are causing rotation in this direction, so that's clockwise, so it's going to be negative. Okay, let's see if we keep going around. We've got this 2,000 right here. Okay, and that's causing a clockwise rotation as well, so minus 2,000 pounds. Okay, and its moment arm is whatever the distance is from B up to G, which if this is 4 feet and this is 12 feet here, that means this is 8 feet. So you can start to see why perhaps my choice of B was not very inspired, right? Because the geometry is a little bit more complicated. Okay, and so then let's do this one. Let's see, so that one's going to cause things to go this way around B. So that's going to be a positive. Maybe that's going to be our only positive. So that's going to be 64.1 pounds, not kips. times its moment arm, which we need to drop a line here. We need to figure out what this distance is right here, which is this number plus this number. So that's what, 13.856 feet. Okay, so there's my right angle. And then let's see, this 1,000 right here, okay, it's 8 feet plus another 8 feet. So that's a 16 foot, because again, here's my right angle. Okay, and that one's causing things to go this way, which is a rotation of a negative. So we'll do negative 1,000 pounds times that 16 feet. Let's see here. And then we've just got this one last 1,000, which is going in the same direction. But it's only got this 8 feet right here. Here's its right angle. Times 8 feet equals 0. Okay, so again, I said there should be 6 terms. So 1, 2, 3, 4, 5, 6 terms. If I check them relative to my key to make sure that I didn't, botch this, we end up solving this, and we end up getting CE equals negative 2,000 pounds, okay, which matches the answer we got the first time I solved this. So that's encouraging. All right, so now we know that we figured out our one force in the Z, and that's one of my X direction forces. So this thing goes down to 2. The problem with these two, of course, is that they both have 2 unknowns. They are luckily the same unknowns, so we can simultaneously solve these. Okay, so simul solve, as we did it. That's what we called it when I was in high school. Okay, so it doesn't really, if we're gonna have to simul solve, it doesn't really matter which ones we do first. Again, like I haven't written these here, but let's go ahead and do this. This is 500 pounds. This is 866.0803 pounds, okay? That's just from the geometry, Anyway, so notice that it's the same here. I'm just not going to draw it twice. Okay, so let's do, it doesn't matter since we're going to have to do both of them, both X and Y. So let's just go ahead and do X first. Okay, so in the X direction, let's see, I've got CE minus CE. I've got BD minus BD times the cosine of, let's see, there's a 30-degree angle for that one right here. This is getting really messy. Okay, minus BE, which has its 30 degrees. All right. Okay, so that's both of these two. Those are our 2 unknowns. I'm going to add these thousands. So they've each got a 500 down here. So plus 2 times those 500s. Okay. And then I've got this 2,000 right here, plus 2,000. Then I've got a minus 4,000 here. Come on, minus 4,000 pounds. And I think that's going to get us all the way to 0, okay, if we add up all those. Okay, the one thing that we need to do here is that CE we need to put in, in place of CE, a negative 2,000. Okay, so if we do that negative with that negative, these two are both going to go positive, right? Okay. So if we do some algebra on this, and it's gonna, it's a little annoying, but we end up with BD plus BE equals 1154.7 pounds, which of course this is the same equation 1 we got for the last time we solved this. I mean, it's the same equation we got in the X direction, so it's kind of interesting how that works. Okay, so I'm going to do the sum of forces in the Y direction equals 0. Okay, and we're just going to start, plugging away. So I'm not exactly sure where to plug away. Maybe I'll use purple for this so that my circles can. So I'm going to start by doing, these negative 866.03. So I've got 2 times negative 866.03 pounds. Okay, plus this one, plus 34 64.1 pounds. Oh, and then I've got minus BD sine of 30 degrees plus BE sine of 30 degrees equals 0. Okay. Let's see. So if I zoom in on this one, this is a bit, obnoxious because now it's in this horrific purple color. Then we can solve this, and I'll get, I think I kind of manipulated this in such a way to give me the same equation I got for the last section, but, I don't think it wasn't really that trying to do so. So it comes to something like this. So we'll call this equation 2. Okay. And again, just like, if you watched the section from earlier, I noted that, if I add these equations, this positive BE and this negative BE are going to cancel. So in this case, rather than doing my usual substitution, I just add them, because then I get 2BD equals 40, what do I get? 46, 18.8 pounds. So if I solve that, I get BD equals 2309.4 pounds. Okay, and then I can plug that in to either of these two equations, just to be different. I'll plug it into this one, and we'll get, let's see, so 2309.4 pounds for BD minus BE equals 3464.1 pounds. So if I subtract that 2300 from both sides and then change the sign, I'll get BE equals negative 1154.7 pounds. Okay. So then, here are my three answers, right here, right here, and right here. So now is the time for rounding. So we'll say BD, BE, and CE. Okay, so BD is 2.31 kips. BE is 1.15 kips. And CE is 2.00 kips. And these are in compression because they had negative signs, and this is tension because they had a positive sign. And I assumed everything was in tension. Okay, so I think if we zoom out, we will see that we get the same answer here that we did over here. And so far, so good. Okay, so that's solution 2, and let's go to solution number 3. We're now 52 minutes in. Okay, so this will be joints. Okay, and I'm tempted to solve the joints all the way for you, all the way to the ends of the earth to prove that this thing works. But it's late and I'm tired, and so I'm going to be lazy this time. I've been doing this now for 53 minutes. And actually, you don't see it, but I actually screwed this up twice. I screwed it up because once I screwed up the geometry and it ran through everything. It was one little careless error. And then the other time, I forgot while solving it to include an external force. But anyway, so what we're going to do here, now with joints, you can start on the left, you can start on the right. That's kind of up to you. But I am going to start on the left. And the reason that I'm going to do that is because if I hadn't just solved for the reactions here, then I would have to do that. Okay, and I don't really want to do that. It's fine now because I've already done it, but I'm going to just kind of walk my way from the left to the right. And what I'm going to note here before I begin is that I only have to get to right here to, because these are the members that I'm after. These three right here. Okay, if I wanted to, if this were a test, right? You've seen my tests. What I would do is I would write over here like this, and this would be, there'd be a blank and a blank and a blank, and I would write TC, TC, so you could circle tension or compression. Okay, but anyway, the thing is, we only have to go to there. If I start with the right-hand side, so if I start at G, for example, well, I need to know what the external forces are at G. So I'm going to need to know the reactions first. Now, I've already solved for the reactions. So in this case, that wouldn't be so bad. But if you haven't done another way of solving it, then it would just add an extra step. So what I'm going to do, I'm going to start at A right here. The other nice thing about doing it this way is I don't need very much in the way of geometry. So of all the geometry that I've done so far, the only thing that you're going to need here is this. You just need angles. So this angle is 30 degrees and this angle is 30 degrees. I think that's the only geometry you're going to need here. You don't need distances because we're not going to be summing any moments because we're just doing joints, right? Okay, so I'm going to start with joint A. And unlike the other ones, you're actually going to watch me draw these because they're, relatively quick. And that's the only reason. Okay, so we've got this, we've got this. I mean, that's the whole joint, right? It's not like, you don't have to be some kind of wizard of drawing to do this. So here's the forces. I'm going to keep with my colors that I've been using this whole thing, which is that blue will be my forces. And this 1,000 is going to be going at a right angle. Okay. Now we will note from earlier that if you want to split up that 1,000, and you will, that this downward portion is 866.03 pounds. And this one right here is 500 pounds. Okay, so that just comes from the angles. And we've been using that this whole video, right? And so this angle right here is 30 degrees. Okay, so boom. So now we just got to figure out which one we're going to do first, X or Y. We'll note in the X direction there's two unknowns, so we'll start with the Y direction. So sum of the forces in the Y direction equals 0. So I'm left with negative 866.03 pounds. And then plus the vertical component of AB, so that's going to be AB times the sine of 30 degrees equals 0. Okay, so if we solve that, we say AB equals 1732.1 pounds. Okay, and then we'll do the X direction. So sum of the forces in the X direction equals 0. So now there will only be one unknown because I know AB. And so in the X direction, I've got this 500 right here, 500 pounds. I've got plus AB cosine of 30, so the X component of AB. I've got AC, which is what I'm looking for, equals 0. Okay, again, I'm going to plug in for AB, 1732.1 pounds. Okay, and 1732.1 pounds cosine 30, I believe, comes out to 1,500. So AC is going to equal negative 2,000 pounds. Okay. Now, and this is something, well, let's just go ahead and we're going to walk into this problem with joint C. So this is joint A, right? So usually it's a good idea to label, your free body diagrams. I mean, I guess technically it's labeled right here, but so we're going to go to C, and hopefully you're already seeing what's special about C. And if you see that, it's going to save you some time. Okay, so here's C, and I'm just going to draw it for you, and hopefully while I'm drawing it, you can think about what makes it special. Okay, I mean, we're all special, right? But joint C is especially special. All right, so that's a right angle. Not that it even really matters in this case. And so I know AC is going this way, which is, actually, I take that back. AC was drawn wrong, so AC is actually compressive, right? So AC is pushing with 2,000 pounds. Okay, I know at joint C I've got CE going this way, and I've got, BC going up. Okay, BC going up. Okay, so let's do this. Let's see. Do we want to go in the X direction or the Y direction first? It doesn't matter here, right? There's one unknown in each direction. Yes, this was something we figured out from the geometry, was that was a right angle. So let's go in the vertical, because that's the special bit right there. There's only one force in the vertical, BC, so that one equals 0. So you're right, BC is a zero force member, right? And we should have spotted that before we ever had to do anything here, because it's going to make our lives so much easier. And the reason that we know that is because this, AC and CE are collinear. They're aligned. There's no external force at C. So the third member is a zero force member, okay? And we just proved that mathematically right there, okay? All right, so now we're going to do it in the x direction. So sum of the forces in the x direction equals 0. And so we've got 2,000 pounds plus CE equals 0. So CE equals negative 2,000 pounds, okay? So that is one of the things we were solving for. So we're pretty happy with that, okay? I will note before I go on to do the next joint that if we go up here, notice there's another zero force member, and it's right here. So if you had to do joints for this entire problem, the way you would make your life a lot better is you would say, well, look, EF and FG are collinear, they're aligned. And so this one right here is a zero force member because there's no external forces at F, okay? So zero force members will make your life a lot easier, okay, if you learn to spot them, okay? So anyway, so we are going to do joint B right here. And I think I'm going to do it right up here because, why not? One thing that can be helpful here too, and I should probably just go ahead and do this, is to draw your answers on your frame. Okay, I shouldn't erase those angles. I'll redraw them in a second. But it can be nice to draw the answers. It kind of gives you an idea of what's going on, where you're going, all that other stuff. And it just kind of clarifies what's happening. Okay, so I'm going to, first I'm going to redraw those angles because they're kind of important. I'm going to do them in a nice dark black. Okay, now I'm going to draw my answers on here. So AC was negative, so that means it's compressive, which means AC is pushing against that joint, and it's pushing against that joint with 2,000 pounds. Okay, 2,000 pounds. We also discovered that CE was compressive, so it's pushing on this joint, and it's pushing on that joint with 2,000 pounds. So it happens that that's one of the answers we're looking for. AB was a positive sign, so it's tensile. So it's pulling on this joint, and it's pulling on this joint with a tensile strength of 1732.1 pounds. Okay, and that's all of my solutions. Oh, and this is a giant ophir. Okay, so what that means is that we can start, it just kind of helps us figure out what's going on. Okay, so when I look at joint B, it should be obvious at this point I have two unknowns. Okay, so let's go over here and let's do a little drawing of point B. And I think that, and then once we've done that, we'll be done with this whole problem. Okay, and I can I can upload this and go to sleep. So anyway, it's what, 11:10 where I am right now. I don't know where you are. Hopefully it's a nice place. Okay, so here's joint B. So I'm going to draw kind of that angle thing here. Okay, I'm going to cut it, right? And then there's this little, BE is coming off in this direction, like that. Okay, and I've got that zero force member, which can be nice to draw, especially in case, you've made an error somewhere and you have to come back and do your work again, right? So now we get that 1732.1 pounds. We've got, what is this, BE? We've got BD, and that's everything, right? And so this is joint B. So as I say, it's a good idea to label it joint B. It helps your professor know what you're talking about. Okay, and so then the last little bit here, of course, is these angles are going to be very helpful for us. Okay, 30 degrees, 30 degrees, 30 degrees, right? And if you're smart, you've noticed I've also forgotten this particular force coming down here at an angle of 60 degrees, right? Or whatever it might be. Let's, I guess it depends on how you want to define that force. But here's my 1,000 pounds. Okay, and this angle is 60. All right. So I'm going to go ahead and just, I'm actually going to solve this two different ways. And I'm going to show you one way that I think could potentially make your life a lot easier. It just depends on, I'm going to show you a shortcut. But first I'll do the long cut. All right, so you'll notice that in the X and the Y, there's both BD and BE. So we can't make this easy on ourselves, except that we can, and I'm going to do that. But first, I'm going to do it the slow way. Okay, so the sum of the forces in the X equals 0. Okay, and so let's see, in the X direction, all of these stupid forces have X direction components. So we'll start with this one. Negative 1732.1 pounds times the cosine of 30 degrees. Okay. Now remember, with this vertical, with this 1,000, we know this is 866.03, and this one right here is 500. Right. So so we can just kind of use that and make our lives a little bit easier. So I'll say plus 500 pounds plus BD times the cosine of 30 degrees, okay, plus BE times the cosine of 30 degrees equals 0. Okay, so that's, anyway, so if we rearrange that, we're going to get BE, or BD plus BE, BD plus BE equals 1154.7 pounds, okay? Sweet. Okay, and then we'll do the y direction. The sum of the forces in the y direction equals 0. Okay, so I've got that, let's see, that's 17, that's a negative 1732.1 pounds times the sine of 30 degrees. Okay, minus, let's do this, 866.03 pounds, plus this BD, plus BD times the sine of 30 degrees. Minus, minus BE times the sine of 30 degrees equals 0. Okay, so if we rearrange all that and solve it and blah, 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 we get BD minus BE equals 3464.2 pounds. Okay, and as I have done, this will be the third time I've solved these particular equations. We're going to add these two equations, okay, which is called simu-solving, where I come from. So 2BD equals, hold on, let's go. You could just go back earlier in the notes and just copy it. 4618.8 pounds. And if we divide that, we'll get by 2, we'll get 2309.4 pounds, right? And then you could just sub that back into either equation 1 or equation 2, and you'll end up getting that BE equals negative 1154.7 pounds. Okay, and that's cool. So now we've got our three unknowns. So let's see. I think I gave myself a spot, right? Didn't I? Yeah, so BD is now 202.31 kips. And that's a positive sign, so we'll make that tensile. And then BE is 1.15 kips, and that'll be compressive because it's a negative sign. And then CE is 2,002.00 kips, and we'll make that compressive. Okay, so going back to this thing over here, if you wanted to make your life easier up here, okay, one thing that you'll notice, and this, if you ever end up in a situation, like either you can just see this right off the bat, or it's like something where you're kind of like, I don't know. So either when you look at this thing, it would be interesting, or it would be nice to notice that this direction, let me do this in kind of like a pencil here, so that I'm not like overwriting everything. But this, it would be a nice, if this were the x direction, right? Notice that, there aren't any angles in that direction. So I'm going to call that x prime. And if it make the perpendicular y prime. Okay. And you can solve your equations on these locations instead of the other ones. And it's, look how many fewer angles I have to deal with. The only angle that I have is a 60-degree angle to that BE, right? So this makes things so much easier. And so we'll solve it that way in a second. But the other way that you can notice that this is lining up for you is that you've got 30-degree angles all over this thing, right? The same angle. You technically have one in here and in here as well. It's just because I did the work earlier that you're not really playing with that 30. So anyway, so if we were to choose to use those as our directions, and this isn't going to be required or anything like that, but if you wanted to do this, I think it would make your life a lot easier. So what I'm going to do is I'm going to do the sum of forces. I don't know why that summation came out so ugly. Sum of the forces in the x prime direction equals 0. Okay, or the sum of forces in the y prime direction. And actually what I'm going to do is I'm going to do the y prime first, because there's only one unknown force in the y prime, and that's BE. Right? Because notice, this one has a y prime component and this one has a y prime component. So I'll say sum of the forces in the y prime equals 0. So I've got negative 1,000 pounds. That's this one right here. Okay. And now I need to get this kind of like this, I wouldn't call it vertical, but this y prime component of BE. And that's using this 60-degree angle. So I'm going to say minus BE times the sine of 60 degrees equals 0. And so I'm going to solve for BE. And my calculator says it's negative 1154.7 pounds. Okay, that's cool. And now I can do the x prime. Now there's more terms in the x prime than there were in the y prime. Sum of the forces in the x prime equals 0. So I've got this thing, which is straight up in the negative x prime direction, so negative 1732.1 pounds. BD is in the positive x prime. Okay, and then BE plus BE. Okay, now I need this side of that BE triangle. So that's going to be the cosine of 60 degrees equals 0. Right? And so what I want to do here is I want to plug in for BE. I want to plug in negative 1154.7 pounds, like that. Okay. And if we solve this equation, we're going to end up with, BD equals 2309.5 pounds. Okay, so I guess there's a slight rounding difference between these and those, okay? Well, I guess these should switch, but you'll see that, it worked the same way, okay? So these are algebraically easier. They might be a little bit harder to see up here, okay? But it's just another option, okay? So anyway, so that's 3 ways to solve this problem. I hope this helps. I know one of you requested it. So anyway, again, remember, be easy. Take care of yourselves, yeah. And hopefully that helps. Note that over here with the joints, you could keep solving the joints all the way till you got to the reactions, and you could check even the reactions, okay? So this is a pretty cool looking thing here. So cool. Thanks, guys. All right. Take care of yourselves. Later.